Fantastic. Hello, everyone. I'm Jonas Thordal, co-founder and CEO of Weld. Welcome to our webinar. We are excited to have you with us. Today, you'll learn how to build a data pipeline using Python, Google Cloud Run, and of course, Weld. We'll be using the Typeform API as a practical example to bring it all together. I'm joined by two of my talented colleagues, Caroline, who will walk you through the agenda and also host the Q&A session at the end. And also David, one of our talented engineers, who will guide you through the live coding portion. And with that, I'll hand it over to you, Caroline, to kick things off.
Thank you very much, Jonas. Yes, welcome everyone. Like Jonas said, really nice to be here and to host this webinar. So our goal today is this, and the comment sessions is to help you feel confident building a data pipeline from end to end. And today we will focus on understanding the key concepts that you can apply to pretty much any API. And my dear colleague David will walk you through how to fetch data from the Typeform API using Python, deploy the connector with Cloud Run, and then plug it into Weld. And after that walkthrough, we'll cover some common challenges like handling auth, pagination, and the schema updates. And we will also show you how to run and host your data extraction pipeline in a way that is production ready. And also, just to set the expectations, we won't go into scheduling or ingestion today, but we have planned to cover that in a future session. So keep an eye out for that. And also, if you have any questions along the way, you can just write them in the LinkedIn comment section, and we will save them for the Q&A in the end of the session. So yeah, just whenever you have a question, write them there, and we will pick them up afterwards. There's any. Okay, so with that, I will leave it over to Dave to kick off the live walkthrough.
Thank you. In this live walkthrough, we will talk about basically consuming the Typeform API. And we will talk about the data schema. We will talk about implementing the data flow itself, handling state and sync logic, authenticating, and also hosting the connector on Google or the function on Google Cloud. And then we will connect it in Weld, because Weld will do the scheduling and ingestion of this data flow. So now I will share my screen and start the live demo. I wanted to start with introducing Typeform, if someone is not familiar with it. So Typeform is this survey creating platform where you can create these various surveys and forms, and then your customers can fill them out, and then you can collect the data and later on just see what they filled out. So for this, we have the API documentation. And whenever you implement an API, the first step is to look at the documentation, because documentation will tell you exactly what to do and how to do it when using the API. So from this documentation, we can see that, first of all, the base URL of the Typeform API is the api.typeform.com. We can see that they have rate limits. They allow 2 requests per second. And we can see that they are using query and path parameters as well. For the authentication, they are using an authorization header, and you will need to pass the access token in this header. And then we can take a look at the endpoints that we will implement today. The first one is to retrieve forms. And Here's the endpoint after the base URL. And then you can also see that they are using pagination with page numbers. You can also define the page size. You can add sorting and the order of the items. And here you can see that when getting a successful response, you get the items which look like this. And the other endpoint that we will look at is the form responses. To retrieve responses, we will need to pass the form ID in the path and then get the responses from that. We can also do pagination, and we can also filter by since and until. And at the end of this page, we can also see how the answers and these items look like. So now let's start by looking at some code. In this demo, we will walk through the extraction and the transformation steps as a Python script, which will be run as a Google Cloud function. And then we will utilize Weld to get the data from this Google Cloud function, and then it will do the loading step. We will look at getting the data, cleaning it, and then sending the response in the correct format. First, we need to import some packages. So because we are building this for Google Cloud Functions, we will need the functions framework, which is Google's package to handle Google Cloud Functions. We will use environment variables, so we can import the OS package for that. And to request the Typeform API, we will use the requests package to handle JSON data and also do some cleanup. We will use JSON and pandas. So let's run these imports. And then we can take a look at the next step, which is calling the API. In this function, we define the endpoint and the parameters as inputs, and we can build the URL that we will call with the base URL and the endpoint. In the headers, we will set the authorization header entry as seen in the documentation, and it will contain the Typeform API key from the environment variables. To get the response, we can run the requests.get function, and it will get the URL, which is the base URL and the endpoint together, the parameters and the headers. Then we can check if the response is successful, and if it's not successful, then we can check if it wasn't successful because of a rate limiting issue. As we've seen that they allow 2 requests per second, we can just wait for a bit more than a second to replenish those rate limits. Otherwise, we can raise an error for the status that we got. If the response was successful, then we can return the response JSON, which will turn the JSON response into a dictionary in Python. So if I run this with the forms, here's the response that we get from the API. And it contains some additional data, such as the total items and the page count. And then it also contains the items themselves. And as you can see, this items list contains two elements. And then you can see that it has some unnecessary data, which is just reference for other things, such as the themes and display responses. We won't need this in our data warehouse, so as the next step, we will do some data cleanup. To clean the data, I created a function that takes in the items and then loops through them. And using pop, it removes some of the keys that we don't need. That's the theme and the self and the links keys. And then in order to be able to append additional data, which will be important when looking at form responses, because the form responses won't contain the form ID, we can also add additional data in this function. Then I will also do some flattening of the data, just to make sure that we don't have this settings nested object. So when I'm running the data cleanup function, I get the clean data, and it doesn't contain those unnecessary fields anymore. It's flattened and it's ready to be ingested into a data warehouse. In order for the form responses to work, we will need all the form IDs available. So for that, I created this helper function, which will loop through all the pages inside the forms and collect the form IDs. And when running it, you can see that I have 2 forms, so I will get 2 form IDs in this account. And then, because the forms and form responses handle the request quite differently, I needed to create a get endpoint config function that will decide which object I would like to get from the API. And then it will create some configuration so I can call the API accordingly. And in case of the forms, we will need the endpoint as forms, and then the pagination will be based on page numbers. I also set the maximum page size, which is 200, and then a new state, which will be used for the next call, which I will explain a bit later. The form response requires all the form IDs. So we will get the form IDs from the previously created helper function. And then we can construct the endpoint by inserting the form ID and then calling the responses. Here, the maximum page size is 1000, which is important because in this demo account, there are no more than 1000 responses, so I can just get them all by setting this parameter. Then the new state will always contain the form IDs list, but only the remaining form IDs that we haven't patched yet. And I also need to set up some additional data because the response from the API doesn't contain these form IDs. So when we call this function for the forms, this is the configuration for the endpoint. And if I call this for the form response, then the endpoint was correctly created and the page size parameter is set to the maximum. I get the form ID data that I can append in the clean data function, and then the new state, which contains the remaining form IDs. The next step in this demo is to set up the ingestion using VAD. And here I would like to share the documentation for VAD for using custom connectors. VAD has custom connectors because we have many connectors, but we don't have all of them. So if you would like to create your own connector, then you can just create an HTTP function or an HTTP hosted service that needs to return data in a specific format for that to be able to ingest this data. So that needs 2 endpoints. One is the schema and the other one is the root endpoint. The schema endpoint will provide information about the available tables, their primary keys, and some fields. Fields are not required because they are auto-inferred by VAD, but by adding some information here, you can define specific types for specific fields. And then in the root, VAD will send a post request with the name of the table that it would like to extract, and then the state, which is going to be the previous state. And here is where state handling comes in, because VAD will always fetch just one chunk of data at a time, and then it needs this state to be able to call for the next page or next chunk of data. And then the response format for this endpoint will need to be with this insert, which will contain the list of items, the state, which will contain the state that VAD should call the endpoint with on the next time. And this has more field that shows if there is more data to fetch. So going back to the code, this is what this get data function handles. it first gets the endpoint configuration based on the name that Weld sends. And then after calling the API, it will also check if there is more data. In case of the forms, the check is made by checking if the current page is already the maximum page count that the Typeform API has. And in case of the form responses, we will check if there are any remaining forms in the state. After that, I can return this data format as Weld expects. So the insert will contain the data, has more will be false, and the state will be empty because we don't have more data to patch. So on the next run, we can start from an empty state. The get schema function is just a static JSON object that we return. And this shows that we have the form and the form response tables, the primary keys, and then I also defined the ID and the response ID fields. The most important part is the handler, because this is going to define these endpoints in the Google Cloud function. When you call Google Cloud function with an HTTP request, then you get this Flask request item. And the request will have the headers where we can define some authorization. So this endpoint is not just callable by anyone, but we can protect this endpoint. We can check if this header corresponds with what we set. This is just something that we can define. And then we can check the request path. If it's the schema endpoint, then we return the get schema function. Otherwise, if it's the root endpoint and post request, then we can do the data flow itself and return the data. So I can show you some example calls using this. This is just the schema function. When calling the schema endpoint, you get this schema JSON object. And if I set up a post request and the name is form and we start with an empty state, then we get the data in the insert, has more is false, and the state is empty. If I would like to request the form responses, then I get the data for the form responses, which is just a bunch of fields and answers. And we still have more data because this was only one form. And then I get the new state. So in this case, that would call the function again with this new state, which I can put here. And then when I call this, we get the responses for the other form, and we have no more data, and the state is empty. These are the building blocks for this Typeform API data extraction pipeline. And here is the whole script. And now I will show how to set this up in Google Cloud Functions. I will click write a function, and I will choose the inline editor. I will give it a name, let's say Typeform demo, and I will need to choose Python as the runtime. I will disable IAM authentication because we will authenticate using the Weld token. I can now set up the environment variables. So I will first get the Weld authentication key, which is going to be secret key. And then I also set up the Typeform API key, and I click create. This will create an initial version of this function, but we will need to change the code so it is our code. I will set up the handler as the entry point, and then I will copy the whole code. And in the requirements, I will need to set up requests and pandas. Then I can click Save and Redeploy. This will now take a bit of time because Google Cloud Run will deploy this version of the function. And until then, we can look into setting this up in Veld. This is the Veld platform, and here we have data sources. I can click Add a data source, and for now, we will use the custom connector. I will create a new connection. I will name it Typeform, and here we need the self-hosted endpoint. In Google Cloud Run, the endpoint is this one, so I will copy this and paste it into Veld. The bearer token will be the secret key that I defined as the Veld secret key. Now I can press connect. And we should be connected to the Cloud Run function. I will just wait for this to complete. And here in the Veld setup, we have this option to deduplicate. This is useful when the source tends to create duplicates, but with Typeform, this is not the case, so it's not going to be needed for now. If I press next, you can see that Veld correctly identified these tables and the data inside them. This is how it auto-inferred the fields available, and then it also defined the primary keys based on the schema. I will set these to always run full syncs because we don't have an incremental setup on this. So I will click next, and here I can select the scheduling. For now, I will leave it on every day, but if you need shorter times between refreshes, then you can always choose a shorter period. And this is the destination schema name. This is how the data in the data warehouse, the schema will be called, and the tables will be as we set up previously. I can start the initial sync now. And this immediately queues and starts syncing data through the Google Cloud function that we just set up. This takes a while, so I will just show one that I already have set up. You can see that this completed. It synced 2 rows for the forms and synced 10 rows for the form responses. We can also preview the data. So this is the data that we extracted from the Typeform API, and now it lives in a BigQuery data warehouse. So you can start querying it. You can start getting insights based on this data. And this concludes the live demo of creating and setting up a data flow and then using Veld to ingest it. And now I would like to talk about some common challenges when implementing an API and a data flow with an API. So not all APIs are consistent in how the API schemas are made. Some APIs might contain custom data where you don't know the schema of the data upfront. In that case, many APIs provide endpoints to fetch this information, and then you can create your own schema based on that. Otherwise, it's also good to just sync the data in a raw format, maybe as a JSON, and then later on in the data warehouse, you can do all kinds of transformations to clean it up and and yeah, see what else is in there. Another challenge when working with APIs and building data pipelines is authentication. In case of Typeform, the authentication is quite simple because they only need authorization token. But in some cases, the API requires auth authentication. And with auth, you get short-lived tokens that you will need to refresh. So this also needs to be built into your data pipeline to always make sure that you have a fresh token that you can use to request data. Then managing state across things is something that we see when we create incremental things. You ideally don't want to fetch all the data all the time. So you need to keep track of what was the last data that you fetched. And then on the next run of the data pipeline, you would like to only fetch data after that. So for this, you need to keep a state somewhere to make sure that you can continue fetching data from where you left off in the previous sync. If you use Weld for ingestion, you can just send back the last state when you have no more data. And Weld will store this, and on the next run, on the next scheduled run, it will call your endpoint with this initial state. Then another challenge is deploying and debugging locally. So as I showed you, Google Cloud Function is one way to deploy data pipeline. Then you can use various tools to call this function. You can set up a schedule to call it, or you can just trigger it manually. But when debugging and working with this locally, you might need some additional tooling. For example, the functions framework Python package for Google Cloud Function gives you a debug server that you can just run, and then you can test endpoint calls towards your Cloud Function. And yeah, other cloud providers can also give you additional tooling for this. Then monitoring and logging is something that, depending on your choice of hosting, it might be an out-of-the-box solution. For example, in Google Cloud, you get a logging view where you can see the calls that were made for the Cloud Function. You can also see the errors, if any. And in Amazon AWS, you also have this. But if you are going with a self-hosted solution on a Linux server or something like that, then you might need additional configuration for logging. Yeah, these are some common challenges that I wanted to mention.
Thank you so much, Dave. I hope that was useful and gave you all a solid overview of how to build your own data pipeline. That was our walkthrough. So I guess if we have any questions, I can't see any questions in the comment section. We had one. I see that Roxy already replied to that we will share some more materials on this afterwards. But maybe Jonas, I mean, you have a lot of experience in this as well and know what the customers often ask us and so on. So maybe you can just add something about the frequently asked questions.
Yes, of course. So maybe you can talk a bit about other programming languages that can be used. Now you presented this one in Python, David, but maybe you can talk a bit about alternatives.
Yes, so any programming language can be used really, as long as you can create API calls and yeah, like consume these APIs and create data pipelines. You can use anything. Veld also supports any programming language because we only need an HTTP service to have these specific endpoints exposed. So yeah, it's completely independent of programming languages.
Great. And maybe another question. So is it possible to use a hosting provider other than Google Cloud? You briefly mentioned AWS.
Yes, there is AWS where you can maybe host it as a Lambda function or just a normal ECS service. That could also be on Microsoft Azure. You could host it as a cloud function. Yeah, or maybe something like DigitalOcean where you just get a bare metal server, and there you can also expose web service. Yeah.
Thank you. And maybe last one then. So I know you also talked about this briefly in your demo, but can you maybe elaborate a bit more on what you can do if the API restricts the number of requests? Because that's usually a big problem, that you cannot just ping the API continuously.
Yes. So when working with APIs, I would always suggest being a bit more protective. So meaning that you don't want to just have your code ping the API and let it be a fire and forget. So maybe you would like to react to rate limiting errors like we've seen in the code, but it could also be that you have a preset amount of requests that you can make in a preset amount of time. And then you can basically create some timings inside your code that makes sure that the requests are spent in this time frame. So maybe if you have 60 available requests in a minute, then you can always wait a second between each call. And then you can be sure that you will never reach the rate limit and never run into issues.
Perfect.
Nice.
Thank you.
And I see now that we have got one question in the chat, and it's on the topic of monitoring tables, fields, and data types often change. Are there any best practices that help flag these changes?
So at Veld, whenever a data type changes, we will always try to update it in the warehouse if possible. So for example, if a number changes to a string, then we can easily stringify the values and then continue to sync that value as a string. But yeah, if the data type changes significantly, or if there is a removed data type or removed data field, then you might need to do other measures. For example, one thing could be that you don't want to work with broken data where half of the items are like this and the other half are like that because they introduced a change in the data type. So then you can just refresh the whole table, meaning you can resync and remove the old data, resync the whole table, and then you will make sure that all of your items are in the correct type. I hope this answered the question.
Yeah, perfect. And I guess, of course, if you have any other question that comes to mind after this, you can just reach out to us at any time. So I guess that was all from us. So thank you all for joining. And like we said earlier, we will send out this recording and also some additional resources. I know we're working on a more like step-by-step course. So yeah, keep an eye out for that. And of course, we have a lot of more information about data and so on our website as well that you can check out. Okay, so thank you so much, Dave, for this walkthrough. And Jonas.
Thank you.
Thank you, everyone.
Thank you.
Bye.
Bye.
Bye.